Hi, my name is Amari Owens, and this is my Physics Lab 3. The introduction for this lab is the purpose of this lab is to explore gravitational interaction in multi-body systems using Python GlowScript code. With this code, we can estimate the mass of a black hole from star's orbital motion and then simulate a spaceship navigating a stable orbit influenced by both the moon and the planet. Some important concepts that we have to first cover is the concept of F net force, which is equal to the change in momentum over the change in time. The velocity update equation, which is equal to final velocity, which final velocity equals initial velocity plus F net force over mass times the change in time. A position update equation, which is final position equals initial position plus average velocity times change in time, and then universal law of gravitation, which then suggests that the universal constant of gravity times mass 1 times mass 2 over r squared times r hat. And then we have just like the mass of like using finding mass using the universal equation. So you have like F net over r squared divided by g and the first mass. Here in my part one, we have the final picture of the result, which we initially like calculated the mass of the star. So first, we would calculate momentum by multiplying the initial star mass and the final velocity we get previously. Um, no, sorry, that's not how we do it. First, we calculate position by calculating the change in change in distance from like first position to second position, and then we multiply that by we divide that by time so we can get velocity, and then we finally multiply that by the mass of the star, and basically we will get delta V and delta P, and using F net, which is change in momentum over change in time, we can find Newton's second law, and then third and finally we calculate the perpendicular and parallel forces by constructing p hat, which just kind of points in like the direction of motion, and then we do like the dot product to get the magnitude, but we do it with p hat and dp dt, which is the f net, right? And then we multiply that times p hat and we get what we want, which is f net in parallel force. And then for that, and then to calculate perpendicular, we just simply subtract parallel force from perpendicular, and that's what we get. In part two, simply we have we calculate the distance from the moon to the planet and the moon from the ship, and basically we just kind of calculate the universal gravitation of both versions, and then we add that to get F net on the moon essentially, and then after that we recalculate again from the ship's perspective, right? So we do that, and then um, we then update both falling velocities, and then apply the gravitational equations to get our desired result. Some potential issues with this was the modeling simulations and probably ignoring the actual effects of approaching a real black hole, which would be very deadly and very unpredictable. In terms of accuracy, there might be some issues with the numbers. So question part one, from part one asks, it was like the difference between like net force and parallel net force and perpendicular force. Well, like parallel net force simply just talks about like the change in like kind of speed of momentum. So it's like change in speed, so how fast is it going, or if it's slowing or accelerating. And change in perpendicular just kind of talks about the change in direction. While net force kind of talks about like the invisible and visible influences that we kind of see on like the acting on the object that we can like usually measure in math. To kind of solve part two, we need to essentially calculate all the forces acting on every object in the system basically, and that's how we get the solution.